Welcome back. Today I'm going to be doing number 200, Leetcode problem number 200, number of islands. This is a very good problem to practice if you're going into interviews um, or just trying to keep your skills very sharp. It's this problem covers both depth first search and breadth first search, so it's a good problem to have under your belt. So first, we're going to try reading through the problem statement and understand what we're trying to do. So given an M by n 2D binary grid, which represents a map of ones, which are land, and zeros, which are water, return the number of islands. An island is surrounded by water and formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So essentially, an island is a 1, 1, 1, 1, 1, 1, 1, 1 that is all connected together. So my first approach is going to be essentially going through this 2D grid, and anytime you find a 1, from there, we're going to be like, okay, we found an island, so increment the number of islands that you have, and then also explore, start a search, just explore down, 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 right, 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 all the way around, and anytime that an adjacent block is land, you recursively do it again. You search, is that one connected to any of them? And after you visit it, and after you visit all its neighbors, you sync it. You essentially just mark it that it's been seen, right? So we don't like find the same island later on, and we find another node of the same island later on, and try marking it again as another island. So first, we're going to start off with just initializing our variables. So we'll just have an result equals 0. Or yeah, we can just start off with that, and we're going to return this at the end. Okay, and then we'll have to iterate through all the cells of this grid. So we'll just use a simple for loop equals 0. Oops. I is less than grid dot size plus plus I. And then for the double for loop, we'll go in one level deeper. J is equal to 0. J is less than grid at 0 dot. And we could do dot at 0 or at I. It doesn't matter because it's m by n. So all the rows and columns are going to be consistent. Plus plus j. And then here, if the current cell we're looking at, grid at I, j, is a 1. Oh, it's a string. Oh, this is a vector of characters. Okay, so equal 1. We want to search, or I think a better way to say it is explore. And also we want to increment our result plus plus. That means we found one additional island, and then we're going to explore. So at the end, we'll just return result. So yeah, the only thing left right now is to actually implement our explore function. So it'll just be a void because we can pass in this grid by reference and then just modify the actual grid, since there's no constraints about not modifying the original input. And we'll just name this explore. We'll have to take in the grid, obviously, and we'll pass it in by reference that we can modify it. What else? We're also going to have to take in our current coordinates, I, j, and yeah, that is essentially all we need. Okay, and then we're going to have to check if we are out of bounds, first of all. We're going to have to do kind of a check. So if we're going to have to, since this is going to be a recursive function, first we're going to need our base case. So if, first of all, if grid at I, j is equal to 0. So if we're not on, if we don't have land, if we don't have any land there, we'll go ahead and return. And then also, if we are out of bounds, so if I is greater than grid.size, greater than or equal to, or if I is less than 0, or if j is greater than or equal to grid at 0 dot size, or j is less than 0, right? So let me quickly just explain what this means. So let's say we're here at this one, actually this one right here, and then we call this explore function. We're going to be exploring everything above, to the right, below, and to the left. So we call this explore function recursively on this 0, and it should terminate. We don't care about anything. We're not going to be marking that as seen or anything like that. It is irrelevant to us. We check the right, we're good. We're going to pass by this space case. It's not going to be triggered. And we can continue. And then the one on the left, there is nothing. It's out of bounds. So we catch that, we return. And above, we'll check that, and we'll see that we have a 1. Okay, so we want to mark the current cell. So grid at I, j, we'll just mark it as a 0. And this will just signify that it's already been seen. That is, it has already been accounted for. And then we also want to recursively call explore on everything above, on the cell above. So that's +1. I guess that is +1. And then -1. So that is the one above, below. There we go. There we go. This should work. Let's see if this is working. Awesome. Memory usage less than 84%, runtime less than 54%. There we go. Thank you guys very much for watching.